So, welcome back. So, in this session, we are going to solve another DSA problem, which is majority element. So, let's try to understand what is the problem statement. You are given an integer array, let's say nums equal to 3 to 3, and it is mentioned that there exists one particular element inside that array that occurs more than n by 2 times of the array. So here n, the element 3 occurs more than n by 2. So we have to return that particular element. Here the output would be 3. Let's take another example. If nums was 2 2 1 1 1 2 2, here total n is 7, n by 2 like 3.5, it could be more than 3 times. Which is occurring more than 3 times? That is this 2, 4 time occurrences. So the output anticipated is 2. We have to return that element that occurs more than n by 2. So how we can do that? So we can do it in multiple ways. Let's start with the brute force, like counting it. Brute force. So how I am going to start brute force is that I am going to keep one pointer here I, another pointer j here, and fixing this particular element I am going to traverse j and see how many times it has occurred, and if that occurs more than n by 2 times, that's what I want to return. So I think let's go directly to solve the problems, and while recoding I will explain you in much details, so that way it would be better you can understand. So this is the class definition, class solution, and the method inside this thing, majority element, self nums, which is a list of integer. That's it, we just need to return integer. That is the element which occurs more than n by 2 times in the array. So let me start with fixing that one integer. For I in range of length of nums, here I am going to fix the counter, count equal to 0. Then I am going to fix the other pointer for j in range of length of nums, and here I am going to check if nums of I equal to nums of j. In that condition I am going to increase the count by 1. So once this is done, here we can check whether the count for this particular element has surpassed the n by 2 or not. So if count is greater than the length of nums by 2, in that case we have to return nums of I. That's what we are comparing and checking here, nums of I. So it is guaranteed that there exists one element of this particular fashion. So at some point it will return that majority element, and that's it. And what is the time complexity of this particular solution? So here you can see there is a back-to-back iterations happening. So time complexity is order of n square. And what is the space complexity? We are not using any extra list or something like that. So space complexity is order of 1. And what is a better solution? So another solution one could think is, so solution 2 would be using hash maps or dictionary. So let me copy this particular class definition. So I'm copied that definition here. Then what I need here is another hash map. Let it be frequency. It's a dictionary kind of thing. Then I'm going to iterate and store the occurrence for num in nums. So this is how we are going to update the frequency or the occurrence. Frequency of num equals frequency dot get num comma 0 plus 1. And at any point, if frequency of num is greater than length of nums by 2, if this happened at any point, we can just simply return that num, and it is guaranteed that you will get something from here. So that's it. So what is the space and time complexity here? The time complexity, there is only one iteration, but space complexity, you are using an extra space using the dictionary. So time complexity is order of n, space complexity is also order of n. So what else method one could think of it? So there is another elegant solution which is known as Boyer-Moore voting algorithm. That's the next solution. Solution 3, which is Boyer-Moore voting algorithm. This needs a little bit explanation on how it works. For that, I am going to just take the elements of this particular array, because I need that to explain. Suppose these are the elements which I have. Initially, I am going to fix two things: fixing count equal to 0 and candidate initially to none. And while I am iterating through this array, whenever there is count I am going to encounter, I will update the candidate to the nums of I, if I is standing here. And as the I traverse further, I pass here, then I goes here at this particular location. If I again see the same thing, same candidate, then I will increase the count again. Count will be updated to 1 by again. The moment itself it was assigned as a candidate, that time also it got updated. And when we see something else like 1 or something, it will be reduced and when the moment it gets 0 again, the candidates will be replaced. For example, at this point the candidate is 2 and the count became 1. When it reached here, the candidate is same and the count will be updated, count became 2, and this moment it is something different, so it will be reduced, count will be reduced and became 1s, and at this moment it is different, so it will be again reduced and it became 0. And when at this moment the count is 0, so that moment the candidate is replaced by that particular element, that is 1. And at this moment the candidate, the count will become again 1 minus 1 became 0, and since the count became 0, it will be replaced with a new element, that is 2. So that, and eventually this works by this particular algorithm. You will get more understanding when we code it. So basically a kind of cancellation is happening when we traverse through this particular way. So let's try to code it. For that I need the class definition. This is the class definition, and what did I set? Yeah, I need a candidate. Initially it is none, and I need a counter. Count is equal to 0. Then I am going to traverse for num in nums. This is how I can traverse. Then if count equal to 0, that time candidate will be updated as the num. If that is not the case, then what I need to do is that count should be updated in such a way that 1 if num equal to candidate, negative, else negative 1, else negative 1. This will do the cancellation that way, and at the end I just need to return the candidate. So this way we will get the answer we want. So what is the time complexity? Time complexity here is order of n. There is only one time we are traversing. And space complexity, since we are not utilizing an extra space, it will be order of 1. So with that we have solved it in 3 different ways. Eventually we arrived at the best solution to solve this problem of majority elements. So with that I am concluding. So thank you everyone